equals, after the last 9 minutes of your life, S equals 0.318. Next, N equals, N minus 1 equals. Define the random variable X in words. Kalski likes to do this. Okay, it's the effective period of the tranquilizer for one patient in the sample. Define the random variable X bar in words. It's the average mean of this particular sample. Which distribution would you use? Karen's going to answer this because she knows how to use the flow chart. So Karen, can you lead us through the flow chart, step by step, and conclude which distribution to use? First question.
Is sigma known?
Answer.
No.
No. Sigma of the population is not known. Olin Nux, is that clear?
Yes.
Okay, next question.
Is the population normally distributed?
So read the question and find out. The
Yes.
answer is?
Approximately normal, yes.
Yes. So the flow chart tells you to do what?
Use T distribution.
Go directly to the T distribution. So E is equal to T alpha over 2 times S over the square root of N. And S was 0.318 over the square root of 9. And now we need T of alpha over 2. So, and now let's use the table correctly because 95% confidence level. So alpha equals 0.05, or alpha over 2 equals 0.025, and n minus 1 is equal to 8. So we find the intersection conjunction matching point for n minus 1 equal to 8. Degrees of freedom with a 0.05. And I've got mine. So we'll see what anybody else got. So what number did you get? 2.306. So you do the arithmetic and you get your E, from which you can easily construct the interval. So we just calculated the error bound. Once you're done, so what does the interval come out to be?
2.26 and 2.75.
And what was the error bound that led to this?
0.24.
0.24?
Yeah.
Okay, so this is the interval. Now, what does it mean to be 95% confident in this problem? It means that you're 95% confident that the mean of the population is contained in your interval, agreed? You're 95% confident that the true mean of the population is in this interval. A worthy problem. Too easy for a test problem, but a good class problem. Okay, one more topic and we're out of here. I'm missing a few pages. Well, see if I can remember to you that. So I'm going to read problem 133 to you, which did not make it to the Xerox handout I gave you. It's my bad. But if you've got other sources here, you plan to conduct a survey on your college campus, this is problem 133, to learn, in Nowakowski, to learn about the political awareness of students. You want to estimate the true proportion of college students on your campus who voted in the 2012 presidential election within 95% confidence and a margin of error no greater than 5%. A margin of error portion no greater than 5%. How many students must you interview? Okay, now sometimes you have to turn these equations upside down. So this is a proportion. So the error is z alpha over 2 square root of p prime q prime over n. Now, they want to know what n is. So we have to solve this equation for n, which means that you square both sides. Now, when you square a square root, you just get the thing itself. So what you end up with is e squared equals z alpha over 2 squared p prime q prime over n. Now, if you solve this equation for n by multiplying both sides by n, you get n e squared equals z squared alpha over 2 p prime q prime. And now you divide both sides by e squared, you get n is equal to z alpha over 2 squared over e squared p prime q prime. Now in this problem they tell you that the error is 5%. So e equals 0.05. That's given. And you want alpha to be, alpha is 0.05 also. So z alpha over 2 is our usual 1.96. Now, they don't tell you what p prime and q prime in the sample is. So here's a trick that you've got no way of knowing except by having come to this class. If you don't know what p prime and q prime are, you make the most logical, simplest estimate. And what is that simplest estimate? If you have no better information, keep 50-50. So if you have nothing else to go by, and it's not going to, it turns out not to mess you up that bad, then you assume a 50-50 split. 133. So now my point in bringing this problem out is that many times you know what confidence level that you want, and you know the other parameters, and then you have to decide how large a sample you need to cause that to happen. What's the sample size that's going to give you the confidence and the error margin that you want? So you work the problem backwards. You start with a required error margin that you must have. How large a sample do you need to meet that error margin of 5%? So when you put in the numbers on this, what gets out? But I want to punch it in.
Yeah, I did 9.8 or 10.
Sorry?
9.8 or 10. Run off.
I got 10,000. I got 1,000.
Oh no, mistake.
Yeah.
What is needed?
Yeah, you got a square E, so you get those extra decimal places.
Yeah. Let's put this one.
And 1,000's a very normal sample size. Around 1,000? Kyle, you punch it in? What do you got?
1,536.
I got 37, but I'll take it. 1,536. Okay, sample size. So, when you have a fixed error margin that you desire to achieve, and you have a fixed confidence level, then you work the problem backwards and find what sample size you need to achieve those goals. Ma'am?
The 1,536 is only C divided by the error, you didn't multiply by the P.
No, not me, no.
Did you multiply by the P and Q too?
No, when I did that, I got 300.
380?
Oh.
Thanks, I'll take all of those. Okay, now the last problem, which is called +4, +2, +4 method, I'm going to leave for you. It's not an important method, but it just is a way that you can get slightly better statistics on proportion problems. So Kowski mentions it. It only takes 5 sentences to read what she said to do, and she has one problem on it, 134, and we're done. Any questions, comments, suggestions, or remarks? Okay, now the tape will be out there tonight if I can do it, but not likely. More likely tomorrow morning for Iwakuni. Not likely tonight. Yes, ma'am.
Okay, so when we did that calculation, we came down with 1536. How did you get to the sample size of 384?
1536 was this much of it. So this was equal to 1536 times P prime Q prime. So you still had one more step to do.
Right.
1536 times 1/2 times 1/2 equals 384. Okay. This was supposed to be the easy week. Whew. If you feel bad, to think about the people that didn't go through this tonight, what they're going to be facing. This course deserves its reputation, there's no question about it.
So with the question, it's, E equals alpha, and then with the question, you want the P one, right? I have to find that one, it's all messed up now.
Good night.
This one? This one? No? Yeah, E equals. Yeah. I just don't put, they put X equals plus or minus E, and I just write it out instead of
She's the expert? Okay.
Yes.
Okay, so, one of the sample problems is in the textbook. It said that, no, this one was mistake, and then calculate the score and everything else, you have to go through all that.
paper.
How do I now go back and erase it, so you can clear it, it doesn't do anything. So how do we clear the table?
Presentation is like an hour and a half long. Yeah, it's so. But it's, you have to talk for at least 20 minutes, but the teacher's allowed to interrupt you. It's not like this. Yeah, so then it ends up being like
declare this.
freaking a long time. And, I'm gonna circle back. There's one another, when I get home, I'll be tired.
I know, but the thing of it is, there's 11 numbers in there, and this one that you were just doing only had 9. And so it was adding the rest of them in if I can't clear it.
Gonna cram this stuff in up, and then take these out. And then, yes, I did. I'm not talking.
Well said.
Everything that is stored.
I'm not sure that all of them, it's just a mess right now. So, is that okay?
Yeah, or you can leave it a mess as you choose.
Oh,
It's all right.
I did some, but I just, cause I did the first part, all the
Sometimes I
answering,
can't get
and
it.
then I flipped the page and those problems are long, there's only 4 of them, so I just put a.
Okay, so how did you do that? So,
It's
What did
just
we do?
between you and your conscience, because we're perfectly well and happy that you did the homework without all of the bells, whistles, and neatness. So you'll get the same credit, it's up to you.
I'm just gonna, only a few pages I need to read that, and one is just fine.
I know you do that. I know you.
One I'm gonna leave messy though, 'cause I'm like, I'm not
Brilliant.
writing. Why did I put my head on my phone? I thought that was-
that was the easier way to do that one. It was like,
I'm gonna work on
this
it.
nailed, and then I
I'm
couldn't.
gonna use the flow chart on the.
Cool.
It will be included in your quiz
Thank you so
packet.
much. So do you want us to print out anyway, Tina? Do you want us to print it out anyway?
No, because it'll be in your quiz packet.